Hi! Today we're making a carbon fiber part. Here it is, it's already done. I do like to know what I'm getting myself into before I shoot these intros. So this is the finished part that I'm gonna make today. I'm gonna walk you through the process of what worked, what didn't, what the steps are in general. I did make some parts before this. I did try out carbon fiber lamination because I think it's a very fascinating process. Back then I've had some mixed results, some better, some worse. And what I find fascinating about this process is, first of all, you can create parts that sort of defy your expectations of how strong or how light they should be. And also, it's a process that is actually rather cheap to get into. All you need is a 3D printer to get started. So you can use like resin prints for like super high detail finished parts or FDM parts. Both of these work great. And then you need like 50-60 bucks worth of specialized tooling, and then consumables for like 150 bucks. You can get enough material for, I don't know, a couple dozen of these size parts. So it's not a particularly expensive or specialized process, especially compared to like metal fabrication. But sort of what it lacks in initial investment, it makes up for in requirement, in like experience and how to handle these materials, and in labor investment. So this is a process that takes quite a bit of time to figure out, and then for each part you're making, it's just a very hands-on process, which I like, and for one-off parts, it's great, but this is not something that you're gonna mass manufacture. So I'm not gonna be selling these Voron Stealthburner carbon hoods, even though this thing looks incredibly cool. Though you can download all the files that I used for making it. So yeah, I really just wanted to take all the learnings from these previous semi-failed attempts and put it into something that works, that is a sort of a functional finished product. And yeah, I'm gonna walk you through the process. We're gonna start with making a mold. This is designed in CAD, obviously. We're gonna prepare this for laying up the carbon fiber. That's gonna get laid up. And then of course, the part itself is gonna get finished and trimmed and all that. And yeah, I'm gonna show you the whole process. Let's get started. For all the parts I'll be printing today, I'll be using the PLA HT110 from this video sponsor, Voron. This is a tough modified PLA that prints with stock PLA settings, but unlike pure PLA, it can withstand up to 110 degrees Celsius without needing any sort of a tempering cycle after printing. This is actually perfect for the molds I'm making because I'll be hot curing the carbon parts at 40 degrees ambient, and the resin itself creates even more heat, possibly over 100 degrees Celsius as it cures. From what I've seen so far, the Voron PLA HT110 took it all like a champ. Check it out at the link below and use code Voron10 for 10% off your order. So there we have it, there's our molds. I did print the wing mold again from FDM. We are going to process this in the same way as the other one and just retry the wing, see if we can make it look good. But this is the one that is way more interesting. So this is the Stealthburner mold. I did make a test print of what the core is going to look like, the printed core, once we subtract all the material that is going to be replaced by the carbon fiber shell. That sort of does fit in here just to verify that it's the right shape. Of course, it does have a couple imperfections. So you can see the seam line here. You can see the benchy hull line artifacts from going from a large layer to a much smaller layer. And of course, the biggest issue is that, yes, this is a 3D print. So even though this was printed at 0.1 millimeter layer height, these are still layers. And if we add resin to this inside cavity, it's just going to key into any small roughness that it finds into any layer structure, and we will never be able to get our carbon fiber part out of this. Of course, I will be using a mold release with this part, but that can't cover up all the imperfections. So there's 2 steps to get this perfect. First of all, sanding it all down just to get rid of all little nubs, anything that's raised, and then filling in the dip down structures with a resin that's going to remain on our mold. PLA is really tricky to sand because it does like to melt. So I'm going to go with wet sanding, some fine sandpaper, and a sanding sponge. The goal of the sanding process is not to create a surface that is perfectly smooth, but really just to knock down any of the high spots that we might overfill in the next step. So before I start hitting this UV resin with UV light, basically curing it instantly, I do heat it up with a hot air station set to 100 degrees just to heat it up in a very controlled way. I don't want to burn it, but I do want to get it as liquid as possible because I want a layer that is as thin as possible. I don't want to change the geometry of the mold more than I have to. There we have them. These are our two molds, and I think these turned out extremely nicely. They don't even look like they're an FDM print anymore. It's just like one continuous block of material. Now at this stage, these have 3 coats of the UV resin on them. I've given these a proper cure out in the sun and a quick knockdown of the surface just to get rid of any bumps. But before we can start laying the carbon fiber into them, there are a couple more steps that we need to do. First of all, we need to decide what our carbon fiber layup is going to be. I've got this regular carbon fiber twill. This is what you probably associate with carbon fiber. I've got this non-woven stuff, which is basically just one layer going this way, and then on the other side it's going 90 degrees to that. So this is a material that is a bit thicker and also a bit cheaper because you don't have to weave it, so it's not that complex to make. I've also got glass fiber, which is a lot cheaper actually, but it's heavier than carbon fiber, so I don't think we're going to use it. Also, it doesn't look that cool. Once you add resin to it, it just looks like a clear plastic. And then the final option would be this unidirectional carbon fiber, which is really just fibers going one direction. Also very cool look, but what I think I'm going to do is I'm going to stick with the twill. I'm going to do some math to see how thick our layer buildup is going to end up with. And either I'm going to do one layer like this, then another at 45 degrees, and then another at 0, or I'm going to do one of these, then one of the non-woven, and another one of these. The other thing is to get these materials trimmed to rough size before you start soaking them in resin. And thankfully these leftovers that I had from a different project, these are all pretty much the perfect size. This one has a bit of a shift in the layer, so that's going to go on the inside. This one over here, this still looks a lot better, so that's going to be the visible side on the outside. So I'm going to trim these to size, and I'm also going to trim my helper fabrics like the breather fabric and the peel ply to size, but you'll learn about those once we start using them. For now, before we start laying material into these with the sticky resin, we do need to add a separating layer. Otherwise, our resin is just going to bond to our mold, and of course, that would ruin both the mold and the part we're trying to make. So I'm going to add a layer of wax-based release and a layer of PVA-based release. So this is going to stay on the mold, and this should come out with our part, and then we can wash it off. This is the same sort of PVA that you use for support materials in 3D prints. But from here forward, you're going to hear from me from the voiceover booth because this stuff smells, and I'm going to have a mask on. Carbon fiber mats cut surprisingly well with just some regular decent scissors, but the loose fibers do make a proper mess, and you should not breathe these, so wear a mask wherever you can. I did decide to go for the non-woven inner layer. This might make for a thicker layup than expected, but like I said, we can correct for that in CAD. The wax separation layer needs to go in a couple of coats, and the important bit is to get it into all the little nooks and crannies on this mold, because that's where your resin will get stuck to. Once the coats have had a bit of time to air off, you give them a light polish with a cotton cloth, and then we're ready for the PVA separation film. Yeah. The hardest part so far was just getting into the PVA bottle, but once you're in, it's just a fairly thick liquid that needs to be brushed onto every bit of your mold. And with that, we're ready to mix up some resin. This stuff needs to be mixed up 10 parts resin to 4 parts hardener by weight, and once these two components touch, you have 25 minutes before it starts setting up. The resin first gets brushed into the mold so that the first layer of fiber that you lay in has a chance to soak through from below. With some more resin, that layer of carbon fiber is then soaked and pushed into all the little corners of the mold to make sure it conforms to the shape. I did have to trim the carbon fiber here and there because it was bunching up in a couple places. I could have made the mold a bit smoother to prevent that. But this is what we have, and we're going to work with it for now. And from there, it's just rinse and repeat. Add more resin, add more fiber until everything is laid up. Once all the fibers are laid up, I add the peel ply film. This is a special film that gets torn off your finished carbon fiber part once everything is set up. And basically it defines the back surface, where that starts and where that ends once everything is cured. Next up, a good layer of breather cloth. This stuff basically acts as a channel to allow air to get sucked out. It also acts as a sponge to soak up any excess resin that may get sucked out of your part. This entire bundle then gets placed into a vacuum bag. Now you can make these yourself with butyl tape and films, but you can also buy these vacuum bagging bags that already have the valve in there and a Ziploc style closure on them. So that's what I'm using here. The important part here is to actually allow the vacuum bag to pull into the corners of your mold and therefore push all the fibers into the corners. And all that's left to do is to let the resin cure, and for that I'm using my filament dryer set to 40 degrees Celsius, which is the recommended hardening temperature for this resin, and we can check back in the next morning. Alright, so here is our finished, well, non-trimmed part. This was a little bit stressful because the resin system that I was using gives you 25 minutes to work with it, and then it really starts setting up. So that's just about enough time to lay down the layers, pack it all up, and as soon as you start pulling vacuum, this is already starting to cure. That of course is useful because it lets you demold it faster and the part is hard faster, but it also limits how long you have time to work with it. And I think because I was having to rush, there are some issues with this part. First of all, carbon fiber out of the mold always looks gorgeous. But this one has some problems, especially in the corners. You can see up here where it didn't really fill all the way into the corners, into the inside corners, and all the way around as well. There's also a little bit of a problem where I've shifted the fibers and they're not that nice weave anymore, but instead they're sort of spread out, which is also a very common problem. And I think a big contribution to this was the shape that I used for this mold. So any double edges where the fabric has to fold in and then over, this edge right here tends to pull the material out of this corner here. The same over here. So of course this is where the second attempt starts. Not only am I now warmed up again for laminating carbon fiber, but I've also made a new mold. So this area here is a lot more smooth, so we're saving this sharp edge that we really can't fold the fiber into. And also back here I've added a bit of a longer tray section so that this is more of just a half round instead of having this double composite angle that we have to fold around. So this mold has already been smoothed out, waxed, PVA'd up, so this is ready to lay carbon fiber into. I've also grabbed a bit of new material for the job, like this vacuum bagging tube, instead of the pillow vacuuming bags, which are really rigid. This is, I think, a bit more pliable. Of course it's open, so it needs to be sealed up with this butyl tape at the ends, and I will be using my real vacuum pump with a real vacuum gauge with this, just because I don't know how much vacuum I was pulling, whether it was too much or too little. Also, I've grabbed myself some thinner, non-woven material. This should lay down a bit more neatly and shouldn't spring out as much for the inner layers. Let's get to it. Sealing the vacuum bag up with the butyl tape is a process that needs to be done very meticulously. We're relying on the seal to hold a low vacuum for at least 6 hours while the resin cures, and if we have a leak and we lose that vacuum pressure, we might end up with a part that isn't usable. Yep, it does pull vacuum. To give the woven carbon fiber twill a better chance of conforming to the mold shape, I'm actually going with a 45-degree oriented pattern this time. So I'm just turning it on 45 degrees. This is going to allow it to pull into the corners just a bit more easily. The rest of the process is the same as before, but this time I'm just taking extra care to make sure there's nothing that's pulling or bunching up. And between the peel ply and the vacuum film, I'm also giving those extra more material so that they have the best chances of really smooching into those inside corners. There's our part. It's not completely perfect, but it looks much better than the last one. This is certainly usable. And as always, carbon fiber, material properties wise, is just amazing. This is, actually let me bring the scale back in. This is just over 10 grams, and that includes all the flashing, which is going to get cut away. So the final part is probably going to be like 4 grams or something. And this is just incredibly strong, and it feels like absolutely nothing. It feels like a thicker piece of paper. That's it. So for the finishing process, I'm going to clean off this mold. Very satisfying. And then I'm going to add some more resin, pop the part back in, and that should fill out all these little corners that didn't quite get filled up with resin completely. No. This was going so well, but this time it just all stuck to the mold. And this was so hard to peel out, and still most of the resin is stuck in there. Look at this, I've even broken the part trying to get it out. I'm gonna have to reset on this one. Yeah. In case you're wondering, at this point I decided to just focus on getting the Stealthburner front piece perfect, and that extra mold you kept seeing on and off for the RC car wing, we're gonna leave that for another day, for another project. So here is our finished part, and obviously this came out looking amazing. The combination of the red and the carbon fiber just works so incredibly well. But, and you've probably already seen it, I did sort of mess it up again in the very last step, which was putting on a top coat, which is just a clear layer of epoxy after everything is finished. Let's turn this back on. And I don't know if the top coat was too old, or I applied it wrong, or I prepped the surface wrong, but it just started bunching up, pulling away from the edges, and now I've got these pools of epoxy basically on the surface, and you just can't sand them away, especially at the edges where you have all this flat, faceted geometry. So yeah, to put this onto a tool head and onto a machine that I'm actually going to use and I'm going to be proud of, I'm going to have to redo this again. But again, the carbon fiber underneath looks absolutely amazing, and that process worked really, really well. Especially I think filing out the Voron logo here by hand was absolutely worth it. It looks amazing with this red LED, even though, you know, now all my needle files are completely dull. This carbon fiber really eats into non-diamond tools. But yeah, worth it. If you want to try this process yourself, I have uploaded all the files to printables, the mold, the modified toolhead shroud, the trimming pattern, that's all available for download. I don't know how many horsepower this is actually going to add to a Voron. I suspect not very many. This is, I consider this mostly a decorative personal touch part, but I think it sort of fits the Voron aesthetic very well. And, you know, the Voron guys put LEDs on their toolheads, which also, you know, just look cool. They don't do anything, they add weight. So this, I think, is absolutely perfectly on theme for a Voron part. These USB power banks, man. And before I close out this video, I do want to give a shout out to Easy Composites. They do sell these carbon fiber materials, but they were a bit too inconvenient for me to order from them. They do have a fantastic YouTube channel though, where they walk you through the entire process using 3D printed molds, using handmade molds. So if you want to learn more about this entire carbon fiber process, you can check them out. I've linked them here, I think, somewhere. So yeah, that is obviously a fantastic resource, and I've learned a lot from them. But then again, nothing beats doing it yourself and making mistakes and learning from those mistakes, and just gathering some experience like that. I have definitely enjoyed this process of learning and making mistakes and figuring out this process. I will be using this process again sometime, definitely. I hope it was as much fun for you to watch this process, and maybe it inspired you to try this out for yourself too. In any case, thank you for watching, keep on making, and I'll see you in the next one. 1,732 layers were used in the making of this project. No animals were harmed.